It's good now? Okay, sounds good. Thank you. All right, hey guys, my name is Mas. I go by Rain and Coffee on Twitter, and I do research at Mayman 11, which is a fund out of Amsterdam. This talk is going to be about the semantics of rollup finality. It's going to be relatively high level because we only have 15 minutes. But regardless, semantics are pretty important when it touches users fund. And there's a lot of, when talking to people, there's a lot of people that don't understand why are withdrawal times for rollups 7 days for an optimistic one, for example, and why am I forced to go to a specific third-party bridge to even get out? So this is sort of to cover all the different types of semantics around finality, and also to cover the different types of rollups. We'll do current rollups on Ethereum, sovereign rollups, based rollups, and also shared sequencing rollups. So what's first important to understand about finality is that a lot of it is semantics. So it's arbitrary. It's something we've come up with socially in social consensus. And it's very much based on who you ask. So people all have different views of what actual finality is. But there is a few things we can look at that will explain what final finality is. And a lot of this depends on what the underlying layer is. So with Ethereum, there's different reasons for when we get finality. If it is on Celestia or Avail or something else entirely, we'll have different views. So it's very dependent on the underlying layer as well. And basically we get this idea of a certainty of truth and a guarantee of inclusion. Now, these are different. So if I'm guaranteed to be included in a rollup block, I have pretty decent I'm very convinced that I'll have finality at some point. But once we have certainty of truth, it means that there's no way we can essentially roll back my transaction unless we do a hard fork. And this canonical truth, we preferably want to have with economic security. So we can say with a high degree of conviction that this is true. So maybe a quick question before we get really into it. If I say finality is when all data is made available, so all transaction data on Ethereum, optimism is usually between 1 to 2 minutes. Would you say that we have finality? Is it final? No. So if we ask the bridge, the official bridge, optimism or optimism bridge, I have to wait 7 days if I want to go back to Ethereum, which means that it's not really finality if I can't get out within those 2 minutes. And this is because we have to recompute and watch for any fraud, or we have to provide a proof that all of these transactions were correctly executed. Now, if you are a user of rollups, and do you guys use rollups? Good. If you're a user of a rollup, if you're on a single rollup, you don't go anywhere else, finality feels pretty fast. Right? It feels almost instantaneous. But as soon as you start moving elsewhere, this becomes quite difficult. And the reason it feels good is because we have a centralized sequencer that can basically promise you that your transaction will eventually go to Ethereum and it'll be finalized. So it feels pretty good from a market rollups perspective. But if I'm an advanced user and I start using rollups that are different, I go from Optimism to Arbitrum, I go back to Ethereum, I suddenly start to feel, damn, like these finality things, they have hands, like they can really fight back. And it's difficult to get out. And this forces us to go to a third-party bridge, and this adds extra trust assumptions. So I have to go to bridges that have varying different degrees of trust assumptions, smart contract risks, and arguably you'd say you'd want to do the canonical bridge, the bridge that is official or native. And some people do say that this finality is when all the transaction data is posted. But the problem here is that we either have to, as said before, verify this is true, or we have to recompute or watch for any fraud that's happened. So if we ask the verifying bridge, usually it's 7 days for most optimistic rollups, or for CK rollups, some of them have just set an arbitrary period of 1 day, just to make sure nothing goes wrong on the proving side. But usually we would say after supermajority epochs, so this would be 12 minutes, we have finality when a CKP has been posted. So that's pretty quick. Now, as said before, if we really haven't checked for any fraud, or we haven't proven things to be valid for anything that's off-chain, can we really say we have finality? Judging by the bridge, we can't really say that. It becomes easier here if you're centralized to a single L2 because of this centralized trusted entity that we have. So we can sort of come up with an idea of what finality is. We can say that it is when a transaction is irreversible beyond a hard fork. That's pretty good conviction of finality. Or we can say that we can say it was when we can guarantee that fraud hasn't happened. So we have waited enough time, allowed enough people to recompute, to watch. Or that we have proven it to be valid with a CKP, or validity proof. Now, we came up with this model to sort of understand finality in rollups. This is for current rollups on Ethereum. So essentially what we did was saying we have pending on L2. So this is the commitment or the guarantee given by the centralized sequencer that your transaction will eventually get sent to Ethereum, and there will be computed a new state on this. What we can sort of say here is that this is when I send a transaction on the Arbitrum or Optimism. We get this pending on L2, and it feels final on the L2 side. And then finality on L2 is when we have committed to the state transaction function of this transaction list that we have on Ethereum. We can then commit to that and add it to the rollup blocks. And this is sort of finality on the L2 side. Then we have pending on L1. So this is when you have either the transaction input, what we call call data, or we have the straight transition function. This could be the outputs, and this differs from rollup to rollup on the CK side. And we still haven't waited for the challenge period, so 7 days, or we haven't waited for the validity proof yet. And then when we have finality on L1 for rollups is when we have the dispute period that has ended, generally 7 days, or we have a CKP that's been verified and waited for 2 supermajority epochs. Then we have a small change that is happening after EIP 4844. So things change a bit here. So instead of sending call data to Ethereum, to a smart contract, we instead set it to the consensus clients on Ethereum, and we post a list of transactions, a state root, and a proof of the state root being valid. So this is different from rollup to rollup. So CKSync and Starknet put the state differences, so the outputs of the transactions we get, and Polygon, CKEVM, and Scroller publishing the full-on transaction inputs, just as call data. And these state differences now provide a bigger trust assumption because we don't have the full transaction list available on Ethereum. So unless I run a rollup full node, I can't compute that the state is actually correct. So there's some extra trust assumptions added here. What has to be said though, we can get a lot quicker finality on CKP side when we get a cost equilibrium. So we can put a lot more transactions into the same size proof, and it'll be the same price to verify it on Ethereum. So once we get more users, most of them don't have that many at this point, but if we'll get to that point, it becomes a lot easier to get very quick finality with pretty low cost of verification. Now we have sovereign rollups and based rollups. These work a bit different because they're to some extent reliant on the ordering of transactions on the underlying layer. So if you are based rollups, you send the transaction data to the underlying layer, and you get included in an actual L1 block. And it gives us pretty strong guarantees of things being correct, because we can trust the entire economic finality set, and we can trust the validators of the L1 that have recomputed all transactions. The downside is that you give away all the MEV and all your sort of extractability of profitability. So that is pretty bad. Beyond that, if you want finality for light clients, for example, you have to convince them, because they have to either trust you, an honest full node, or you can provide a state proofs, for example, that attest to this being true. If you're on the sovereign side, this depends on the sovereign, like a sovereign, so it's in the name, right? They might have a consensus algorithm, leadership election algorithm that sort of decides on their own when a transaction is final, but they will all be looking at the DA layer, and they might have a fork choice rule that says every n number of blocks, we need to have all the transactions that were sent to the namespace MickleTree on Celestia or smart contract on Ethereum included in that block. Otherwise, they'll get slashed. This would either be a bond, or it could be verifying a validity proof. Then on the shared sequencing side, things start looking a little bit similar to based sequencing. So in based sequencing, we get block order finality from the underlying layer. This is the same thing with lazy shared sequencing. So the full list of transactions are already available on the underlying layer, and I can compute the new state from that on the rollup nodes. But the rollup nodes still have to execute this and store the new state. But the actual list of transactions is already valid on the underlying layer. And we sort of have two types of finality. We have the soft finality guarantees, which is when all the data is available on Celestia or Ethereum, but hasn't been computed yet. And then we have provable finality, which is when the rollup nodes have computed the new state, and then have either peer-to-peer verified this or verified it in a smart contract. But as long as we look at the underlying layer, we can guarantee that ordering has been correct in a block. Then how do we get strong enough security guarantees in these things? Well, we can either do what sort of most people will likely do is proof of stake committees. So we have some economic bond that is here that comes to consensus over a state root being correct and signs on this being correct. And here you want 66% of all the validators to attest to this being correct. You can also provide a validity proof. So this is what CK Rollup does to this computation being correct. Or you can have the optimistic route, which is where we have signatures from, for example, a single actor or more in a decentralized sequencer set that has a bond that will get slashed if transactions are proven to be invalid. The problem here could be that there might be more plus EV to commit fraud if the bond is too small. And as we said in the beginning, the L1 has different finality trade-offs that might be depending on what you're using. And for now, the way it just works is with a single centralized sequencer. And this changes a lot when we get a decentralized set. Now, why is Finality this way? Why is it 7 days? Well, if we want to prove fraud on-chain, we usually play this interactive fraud-proof game, which is quite computationally expensive. And obviously, Ethereum block space, because of how it's decentralized and how usable it is very, very expensive. And we also have a humongous validator set. I think we're nearing like 900,000. And sending messages between all these validators take a long, long time. And we have to allow all of them to come to agreement. And honestly, this is a good thing. So having this big of a validator set, I think it's a very good thing, but it does add a lot of strain to the network. Now, one thing we can do on the optimistic side is that we can actually CK a fraud proof. So we can off-chain verify that this fraud proof is correct, and then we can send this validity proof that proves that fraud was done, and we can verify that instead. So we can get these hybrid type rollups, which is quite a nice thing. Now, when we start to decentralize these sequences, we run into a problem where it could be like on Ethereum, where we have an unbounded set that's permissionless, and that's fantastic, but it's very hard to prove that all of the actors in the rollup have actually attested to things being true. So it's difficult to get what we call single slot finality. Now, with a bounded set, like we have with Cosmos and Tendermint chains, which is usually 100 to 200 validators, we know exactly who's active and who needs to sign. And this could mean that we can get pretty fast and quick finality times, but you do sacrifice centralization to some extent, and we always know who's available. And it's hard to scale this to a very large set as well. So that's one thing to keep in mind. Now, we sort of come to the end here. So I know some of you might have read about Tron Chabano and others that have said rollups are real, they're not real. I do think they're real, but I don't really think they scale Ethereum block space. I think they scale Ethereum liquidity by providing separate block space that can utilize native ETH liquidity in smart contracts on Ethereum. And they also inherit the censorship resistance, although this is only really partly true at this point because of the fact that a lot of these smart contracts are controlled by a multisig, they're upgradable. They need to be because most rollups don't have fraud proofs. So we are not quite there yet, but rollups are definitely real. And what's really important to understand here is that finality is really just social consensus all the way down. So we agree on some setups that fit us and can allow our networks and our systems to work. And then we wait for the protocol rules that we have in place to deem things final. And thank you.
Yeah, if we have any questions, we have, okay, sure.
Thank you for the talk. It really deepened my understanding. So as like the chapter of public blockchains we are living in now is like the L2 wars, which is horrible as someone creating a dApp, because which L2 do we build on, and what happens if the rollup we build on fails? It gets hacked, it gets rugged, it like doesn't exist anymore. Can we still retrieve our transaction data, or only the account balances as of the last date?
If we have all the transaction data available on the L1 and it's not pruned, we can sort of reclaim everything. But if we're in a situation where we are pruning data after 3 weeks or a month, you have to go trust archival nodes that is holding all the state, which is a bit of a problem, because then you're trusting, in most cases, not a lot of people. And on the side where you're saying with a lot of rollup wars and rollups happening, what you can do with rollups is that you can do a lot of very cool customizable things. So you could, for example, have different sequencing rules. It could be if you're a DEX AMM and you want rules for trades that if they're not, they have to be buy, sell, buy, sell, buy, sell. And then they can only be buy, buy, or sell, sell, sell if they have a better execution on the trade than the beginning of the block. So there's some cool things you can do on the application side as well.
Hey, thanks for the talk. Two questions, if I may. First one is, what's your preferred design to kind of achieve, the best possible finality on L2? And second, do you have a view on Cello's recently announced plans to convert to an L2 with using eigenDA and also a decentralized sequencer using their kind of L1 node operator set?
Yeah, I think on the first answer, I think for now, with the amount of users we have, I think optimistic rollups make more sense. But as we scale the amount of users in Web3, CK rollups start to make a lot more sense because of the density in transactions that we can put into a CKP. But I could also imagine a hybrid world. And what are my thoughts on the Celo announcement? I think it's cool. I think the way eigenDA works to some extent now is more like a data availability committee. And I haven't seen anything about having ordering on the transactions you have there, just data availability, which in some cases, if you want to do like a based rollup, you kind of need that to some extent. But one thing that's cool with /JavaL eigenDA is that it's very easy to scalably scale DA. It becomes more hard to scale consensus, for example, like consensus security. So interchain security and others will run into a problem where supporting chains that are not extremely economically advantageous becomes quite difficult because they're paying more in DevOps and hardware costs as well.
Yeah, guys, unfortunately, sorry, the time is over. You can answer the extra questions outside as we have to set the second speech. But thank you so much.